Welcome to this lecture on process analysis. This is an extremely important topic, not just from the perspective of this course where you do homework on it, it's tested in the exams, but also from the perspective of your career, of real life, of learning how to apply operations management principles. It's a very practical topic. It has a lot of applications, whether you work in a hospital, in a service organization, in a retail store, in a factory. You can apply what you learned today to make things better. And remember that, we experience life by interacting with organizations. Organizations interact with their customers through their internal processes. So they have a process to get customer order, create a product for the customer, things like that. And so if those processes work well, the customer will have a good experience, because all of our life is mediated through organizations. We're born in a hospital, usually, which has its processes. We go through life, through schooling, through university, which are organizations with their processes. We work for a company which has its own processes, HR processes, evaluation processes. We buy stuff that gets to us through different processes. So if processes work well in all the organizations, humanity will have a good experience in life. There will be happiness, there will be satisfaction. And so it's really important not just to make money, but to improve the human condition overall, to have good processes. So what are we going to be learning today? Okay, so our learning objectives include, we're going to look at how to diagram or illustrate processes, how to represent them, how to analyze them. Then we're going to learn about Little's Law, which is a widely used formula to give us some more insight about processes. And then we're going to look at some process analysis examples so that we know how to apply these concepts. Okay, so let's start with process flow diagrams. This is a very simple thing to learn, and you really learn it when you actually do it, because you can look at some diagrams and say, yeah, that makes sense, but you really learn when you actually map real life processes. Because a lot of decisions that you have to make a process flow map, you get the hang of these decisions and you learn the importance and significance of these decisions when you actually try to map real life processes. What are these decisions? The first thing you have to decide is process scope. Where does the process that you're going to map start, and where does the process you're going to map end? You can consider, let's say, the order fulfillment process. That's usually a pretty long process in most organizations. It starts from when the customer first indicates to you that they're interested in a product, right? Sometimes there's some sales process there where the customer walks into your store and then the customer needs some assistance in choosing what exactly to purchase, especially with larger purchases like cars, furniture, buying a home, right? And then the process ends when the product is finally in the customer's possession, but sometimes not even then. Maybe there's a feedback process where the customer can return it within 7 days, or the customer provides feedback about the process, how it went. Maybe there's a returns process. Maybe there's end of life collection process. So maybe it's an electronic item with precious metals or harmful chemicals inside it, and so you don't want the customer to just throw it out in the trash. And so maybe another organization, which or your own organization, is going to go and collect the item at the end of service and recycle it to neutralize the harmful things in it and to extract the precious metals in it and things like that. So just the order fulfillment process can be a very long process. It's very rare that for such a long, complicated process, you are going to try to improve the whole process in one go. You may work on a piece of it. So you might say, okay, I'm going to work on the inventory replenishment process, on how does inventory get replenished in my retail stores or in my manufacturing plant, and you try to map that process. So you have to define a starting point and an ending point to focus on for your process mapping or process diagram activity. Once you define the scope, okay, you have to think of the level of analysis. Are you going to map this process at a fairly high level, which maps the main stages of work, or you're going to map it at an activity level where each activity is something that one individual worker or employee does. Okay? This is, again, a really important decision because that's going to determine the complexity of the process that you end up mapping out. Now, it also will determine how much time it takes you, how much information you need, and so on and so forth. The first time I did this activity in a large real organization, I was surprised. Because just by process mapping itself, you're able to see so many process improvement opportunities, and you're able to do so much that just process mapping itself is a process improvement activity, just documenting how process is happening. And it's hard to perhaps imagine, but in many organizations, there's no one person which knows the entire process for any large, important process in the organization. And that's strange because things are getting done in the organization, so how can nobody know how exactly things are done? People have limited range of vision in an organization. So maybe they know who they work with, who they get stuff from, they know what they do themselves, they know who they pass on the work to, maybe within their function or department they know how things happen. But these employees are not going to have visibility across functions, across facilities in an organization to be able to see the end-to-end process. You might ask, what about managers? Okay, general managers, senior managers, they must see everything. They do have visibility, but at a different level of analysis. So a high-level manager might see, okay, we have purchasing, we buy stuff, we have manufacturing, we make stuff, and then we have distribution and sales, we sell stuff. So he might think of the whole process as 3 blocks. But each of these blocks has hundreds or thousands of steps within it, utilizing hundreds or thousands of employees, working with hundreds or thousands of products and components. So even though the basic visibility is there at the higher levels of management, they don't know in detail how exactly things work. Low-level employees are going to have the opposite problem. They know how the nitty-gritties work for their field of visibility, but their field of visibility is so limited. The other interesting thing I discovered through my experiences was that a lot of times there's no agreement on how things happen. You talk to one person and they say, yeah, when I pass on this thing there, that person does this, then that person does this, and that person does this. And you ask somebody in a different area of the organization and they give you a completely different picture of how the same thing is done. They say, oh no, this person does this, then some other person does something else, and something else happens. And so oftentimes you get competing narratives of what's happening in the organization, and then you have to go to each step and verify, okay, this person said, then this goes there, does it actually go there? Then does that person do that? You have to go talk to that person. So you have to go through, talk to many people, observe many things to get an accurate process map. You can't just rely on employee A sitting in, let's say, a warehouse telling you what happens on the retail store when they receive product, because he may have gone there once or twice, but his knowledge may be outdated. Maybe they changed things. Maybe what he saw was an exception that day. Maybe some employees were fired and new ones hired, and the new ones do things a different way. There are many things that happen over time in an organization. Even if an organization has documented processes, you'll often find that what actually happens in the organization is slightly different than a documentation. Because when you document processes, you are documenting them on how things happen on a particular point in time, a particular day, particular month, particular year. So that's a snapshot in time. But organizations evolve, people change, people go, people come. The knowledge within the organization changes. Different situations are handled by the same process. Some of the situations were not anticipated by the original people who designed the process. So people start doing alternative steps to handle these exceptional circumstances or these changes. People change themselves. Old people leave, new people get hired. And so things start to deviate from what was mapped in the documentation, what was written in the documentation in the organization. This is why, if you think about it, if you took a company, because this is a thought experiment, and you told everybody to write down in detail exactly what they did, okay, like a training manual for their replacement, and then you got rid of everybody, told everybody, okay, you guys go on a vacation, and you brought in new people with equivalent qualifications, so same degrees, same type of number of years of experience, and you brought them and put them into this organization and said, read what those guys wrote, what they did, and do the same thing, right? So you took a marketing manager, you send them on leave, and the new marketing manager comes and they read the description of what the old manager used to do, and they start doing that. But you don't just replace one manager, you replace every single person in the organization like that, right? You will realize that these new people, even though they have documentation from the old people on what to do, the company will not be able to run as it was running before. Okay? Because there's always some tacit knowledge in people's heads, things that they've observed, things that have become habits that they don't even think about as a formal process, that they can't write down if you ask them to write down what they do. And so that knowledge of the organization that's held by the people is an important piece that makes organizations work as they work. And if you just replace all the people, that's not going to be there. Even though the formal knowledge of how things happen is being documented, the new people will not usually be able to run the organization at the same level of performance. It'll take them some time. Then they'll learn the same things the old employees learned as they do things. And after some ramp up period, which could be months or years, they would get back to the same performance. So what I'm trying to say is that even though there's documentation that was written some time ago, even though people think they know how things happen, when you actually go to map out processes, you cannot just trust people's memory. You cannot just trust people's opinions. You have to go measure everything yourself, because you will often observe that what actually is happening is a little bit different, and sometimes in important ways, from what's been documented before, from what people think happens. Okay, so it's really important. So you have to decide on the process scope, the level of analysis. You may also want to think about what's going to be the unit that flows through your process diagram. So you have different steps, you're connected by arrows, right? Let's say you're in a large factory and they do batch production. You might think of a batch. Okay, this is a batch of 1,000 units of production, and we produce in batches. Maybe make a new batch every week. And so you can do a batch level process where a batch goes here, batch goes there, this happens. Often if you go to the lowest level where you want to map what individual employees are doing, so each box in your process map is some activity done by an individual employee, then you have to go to lower units of analysis. You may be at the component level, at the product level. Look at this employee does this with this component, that component goes there. The next employee assembles these 3 components into this sub-assembly, that goes there, right? So then you have to go down to the component, sub-assembly, and product level. If you're a service organization, you may have to go down at the customer level. In healthcare, you may have to go down to the patient level, where this is the patient, then they get moved here, then they go here, then this happens to them, and so on. So what's flowing through your process that people are working on, you have to think about that. And sometimes there's multiple things. Sometimes you are a repair shop and there's a customer is there and their vehicle is there, right? And you have both things there. So process flow diagrams, also called process maps, flow charts, process diagrams, there's many different words for them. There are many different ways to draw them, many different conventions you can use. We are going to deal with some a simple process map diagram in this lecture that most people will be able to see and understand what's happening. We'll use some basic elements to represent tasks, decisions, points, inventory or queues, movement of things, people or things. But what I want you to know is that's not the only way. There are other ways to draw process diagrams, other symbols you can use. If especially in your process, if information is extremely important. Let's say you're processing people's documents, like a passport office, you may want to have symbols to represent databases and how data gets updated to databases, how data gets retrieved from databases, how documents get stored in an archival storage or something, things like that. And so as you learn more about this area, you'll see that there's different types of symbols you can use, different types of diagrams you can draw depending on the context. What we're going to do is a very basic one which applies to most situations and can do a pretty decent job in many situations, but it's not the end all of process mapping. There's other things you can learn and do. Okay, so we're going to look at these four symbols for the most part. We're going to use rectangles to represent some sort of processing happening. Okay, the process could be you talk to a customer, you write down their name and address, and you collect information from a customer. That could be a process. The process could be you assemble a component onto a car. The process could be you cut a piece of wood, right? So a rectangle is some sort of a task or operation that happens. These rotated squares, which I believe is called a rhombus, these are decision points. So sometimes you do something else based on a condition. So if the product is defective, you can send it to the repair shop. If the product, let's say you're testing a product, and so after the test, you have to decide, okay, is it defective? It goes someplace else. And if it's not defective, it goes someplace else and something else happens. So you have branches in your process map, and which branch you take depends on some condition. So that's you use the decision point symbol. Then whenever you have product or customers waiting for something to be done to them, that's called inventory or queues. And so we use an inverted triangle. Queues are basically inventory of people. So let's say you have customers waiting for service. That's an inventory of customers in a way, or you can call it a queue. And then you can have material waiting to be processed, and that can also be called raw materials inventory or work in process inventory, or material that's finished goods waiting to be sold or transported, that's finished goods inventory. So all sorts of inventory or queues, we map them as a triangle. And inventory or queues, you might be thinking they're two different things. Why do you use the same symbol? Because both of them represent something that is waiting for something to be done to it. So this idea of something waiting so that something else is going to be done to it is the idea behind inventory and queues, and so we can use the same symbol. And then solid arrows represent flows of materials or customers. We'll also use dotted arrow to represent information transmission. So if you want to say, okay, something happened here, this information needs to go to some other person so they can start some other task, we can use a dotted line to represent that nothing physical is moving to this other person, but some signal or some email or some information is going to the other person. So we use solid lines for actual movement of physical things, people, customer, component, product. Dotted lines for electronic records, information, things like that, moving through the process. So let's look at a simple diagram. Okay. Here we have 4 tasks that happen in sequence. So task A is done on something, customer or a unit of product. That gets moved to this next stage where task B happens, gets moved to the next stage. See, the solid arrow represent flow of goods, material or customers, things like that. Task C happens, then the next stage, task D happens, and then you're done. Okay. So the tasks are represented by the rectangles. The arrows indicate which direction the product flows in a manufacturing context, or which direction the customer or patient flows in a service or healthcare context. Okay. Now, it's important to understand, we call this a sequential process, right? We say it's a sequential process, task A happens, then B, then C, then D. But if you were to walk into this process happening in real life. Let's say this is a factory process, 4 processing steps, maybe some raw material comes in here. We do 4 steps to transform it into some output, and that's some widget or gadget comes out from the end. Yeah. If you were to walk into this factory, you'll see at station A, task A being done, station B is doing task B, station C is doing task C, station D is doing task D. All 4 stations are operating at the same time. Okay. So why the sequential process? All 4 tasks are happening at the same time. It's not that, when task A is happening, B, C, and D are just sitting idle. And then when task B is happening, A, C, and D are sitting idle. It's not like that. Well, you have to look at a process to see if it's sequential or parallel from the perspective of what is being worked upon. So imagine this raw material, a piece of raw material that enters here. Initially, only task A is working on that piece of raw material. Then it gets moved in some changed form to task B, then only task B is happening on that raw material. Then it gets moved to task C, then only task C is happening to that raw material. Okay. And then it flows to task D and goes out. So when task A is working, let's say on piece 55, task B might be working on piece 56, and task C might be working on piece 57, and task D might be working on piece 58. So they're working on different pieces or raw materials or components, and then when this is done with P50, where is it working on P55, it moves that here, and then this was working on P56, that gets moved here, right? And this is working on P57, that gets moved here, so everything gets moved forward, and this picks up the next one, P54, let's say. Okay, so things move through this pipeline, and if you were to put a camera or just follow any one piece, it would move sequentially through this pipeline or this sequence of tasks. So that is why it is a sequential process. Okay. So tasks A, B, C, and D are happening. Thus, A, B, C, and D are happening simultaneously on 4 separate customers or products. And so although all tasks seem to be working at the same time, working on different components or products, any single product or component, if you track its flow, it moves sequentially through the 4 tasks to completion. So it's a sequential process. Now here's where the level of analysis I want to show you. After I showed you what a simple task looks like, I wanted to show you the level of analysis. Okay, so at a very high level, I could be mapping the process of a clinic, and in this clinic we intake patients, then some provider like a doctor looks at the patient, gives them medication or a prescription, treats the patient, and the patient goes. There's 2 steps: intake, and then the patient gets processed, right? It's a very high level. But if I was to go into patient intake, that might involve several different steps and some waiting. So that inverted rectangle is waiting, where the patient is waiting for something to happen. And the provider treating the patient might involve multiple steps. Maybe it's checked by a nurse first, then goes to a waiting room or a room to wait for the doctor, then gets treated by a doctor. So at a lower level, each step of the higher level process might itself be its own process. Okay? So that's where the level of analysis is really important. What level of analysis are you working on? And that depends on what you're trying to do. Sometimes you want to look at different manufacturing stages, especially if there's been problems in terms of how material flows through the major manufacturing stages. So each stage becomes one box, and just analyze them to see, okay, what's happening? Are their capacities too mismatched? Is one block slowing everybody else down? And then once you identify where the problem is at the higher level, then you go to that problem area and then you map the process at a lower level to find what exactly is going on within that manufacturing stage, for example, or that larger block. Okay. So sometimes in the same process improvement project, you may start at a higher level, but then once you have identified the area where you want to work on, where you want to really improve the process, then you dig deeper and you go and draw a much more detailed process level diagram for that area to see where you can improve the process. Now let's look at another process diagram, and I want to show you the second one because I want to show you what a parallel process looks like versus a sequential process. So this process has like two stages. The first stage, we have three tasks. Fashion the seat. I didn't make the seat or make it nice. Fashion the front legs because we're making chairs. Fashion back legs in the chair back unit. These three tasks are happening in parallel. And the reason they can happen in parallel is that they can all work on different pieces of the wood for the same chair. This is the difference. In a sequential stages, each stage is working on a different chair. But here in the first parallel process, the three tasks, they're working on components for the same chair in parallel. Okay? So we have some inventory of wood. The wood flows into all three of these tasks. All three of these tasks, there's a worker or workers in each one of those task boxes, rectangles, and they work in parallel for the different parts of a chair for the same chair. Then they, they put together these parts into like a kit or in a box or tie them together, whatever, and the chair components are stored. And then the assembly process can start. They can pick up the components for one chair, put them on the assembly line, start building up the chair. Once the chair is assembled, it moves to a staining process where the whole chair is stained or painted, and then is put into the finished goods inventory. Okay. So the chair components are sometimes called work in process inventory. Okay. And then the wood here is sometimes called raw material inventory. Now, although the supplier supplying you that wood might have their own process for which this wood is the output, right? Their input might be a tree. So they take a tree, they get rid of the leaves and branches and cut off the bark, and then it's in a weird shape, so they have to make planks out of it. Maybe they have to do some pressure treating of the wood or let it dry out, things like that. So there could be a whole wood processing process before this, whose output is these nice treated planks of wood. And then for this process, we take those planks of wood and we build different components in parallel. Then we put them together as components. And then we have a sequential part of the process where we assemble those components into chairs and stain or paint the chairs. So I hope you can appreciate now what we mean when we say a parallel process versus a sequential process. Okay. So parallel or sequential, this is very important, is determined with respect to production of a single unit or processing of a single customer request. Okay. In other words, how does a given unit, product, or customer move through the process? If you look at the parallel process part, different parts of the chair are being worked on in parallel. Whereas in the sequential part, if this chair is being assembled, the same chair can't be stained at the same time. The staining will happen only after assembly of the chair is complete. Okay, so that is the difference. I hope that is clear. Let's look at a service process diagram, okay, for a cafe. And you have customer arrives. This is not really a processing task. This is more like an event, right? In this case, this is something that the customer does. So you might want to color it a different shade to represent that this is not something we do. This is something the customer does. Customer can be part of your processes, right? If you look at IKEA, IKEA's processes. After the customer selects what they want to get, they go into the IKEA warehouse, which is part of the IKEA store, and they pull out those flat packs or those boxes of pieces of the furniture, put on a cart, and then they go to check out. Traditionally, before IKEA, this part was done by company employees. Company employees would get the flat packs or pieces of furniture from the warehouse and then bring them out for the customer or assemble them as well for the customer. So customer picking from the warehouse and then assembling the furniture were tasks that the furniture companies used to do, and now IKEA outsourced those to the customer for the customer to do those tasks, and now customer became part of the order fulfillment process of IKEA. So in your process maps, there could be things that the customer does. That's fine. Okay. Usually you want to color code them separately to indicate, okay, this is done by the customer, not by our employees. So the customer arrives, the customer waits. So as I mentioned before, anything that's waiting for something to happen to it we model it as inventory or a queue, which is this inverted triangle. Then the customer places the order and the customer waits again. The order flow goes to the cashier. This is transfer of information. Then from the cashier, the order goes to the people working in the cafe. And then there's a decision point. Should this order go to the coffee person who mans the coffee station to make coffee, or should this order go to the tea station where somebody makes tea? And depending on what the customer order, the information will flow, or the customer order will flow to the different stations. Okay? A customer may order both. So you could have the order get split up, and then the coffee part of the order goes here, and the tea part of the order goes there. Okay. Then, the coffee station prepares coffee. The tea station prepares the tea. And then if the order had both, you need to assemble them together here. So there should be another box here that would assemble the different beverages into one delivery box or something like that, like a drink carrier. And then this will be given to the customer, and then the customer leaves. Okay. So you'll notice that these simple blocks, just any task or anything that's done, waiting, which is inventory or queues, this inverted triangle, decision points, and arrows with these 4 basic shapes, we can map out a wide range of processes in the real world. When you do map processes, I want to point out, and I'm actually going to show you why in the beginning of this lecture, we have this nice stopwatch here. Process maps are very useful, but they become extremely more useful, many times more useful, if on that map you also write timing data. How long does it take to do each task? How long is the average wait time in different queues or in inventory blocks? And when you add the timing information, you're able to do a lot more with the process maps. Now, where do you find timing information? The old way is a manager going around with a stopwatch and a clipboard and pen and paper and timing different tasks or different things that happen, timing how long it takes to move things, timing how long it takes to process in different processing steps take, and so on. And then they would have the times for their process map. With a stopwatch, a pencil, a piece of paper, or a notebook, and a person who knows about process analysis, you can really make some very significant changes in any organization and make it much better. Okay, so from the simple things you're learning here, armed with a stopwatch or some way to collect timing data, you are going to be an unstoppable force for good in your organization, which is why this is a really important lecture. Okay, so that's how it used to be done before. Should you still use a stopwatch? Yes, by all means, stopwatches are still extremely useful. However, there are also other ways to get timing data now. So in a lot of factories or something, there's some video recording going on. So you could look at last 1 month's video, and if the video had a timestamp at the bottom, especially with seconds. You can stop and start the video and see how long different tasks take. You get a sample, okay, this processing step, takes a little bit of different amount of time each time, but on average it takes 5 minutes, maybe plus minus a minute. So you can get all sorts of data like that from video feeds of observing, of a video feed recording people working in the process. At some points, timestamps get created in the IT system. So let's say when components are checked out of the warehouse into the assembly line, the ERP system, like SAP or some other ERP system, might create a timestamp, okay, that at this time and this date, these components moved from warehouse storage onto the assembly line. Then when they exit the assembly line, they go to the finished goods storage. There might be another timestamp created in the ERP system showing that these products at this time assembly was done and they were put in the finished goods warehouse. So looking at those two timestamps, you can see how long certain products or components spend on the assembly line. If you're doing especially if you're doing a high level process map, sometimes these timestamps in the ERP system are sufficient to get the timing data you want. Okay, you want to look at the assembly operation as one block and say, okay, this is how long the assembly operation takes for this type of product. This is how long it takes for this type of product. Just looking at timestamp data in your IT system or ERP system. Okay. But often for low-level process mapping, where you want to map individual activities that individual employees are doing, not every single activity creates a timestamp in your ERP system. And so then you have to go either look at the video feed and get timing of that, or have some sort of sensors where employees who do certain movements, it triggers the sensor and records data. So that's called automated data collection. It's a big area these days in operations where you can buy sensors or these devices which can detect certain events and record data automatically. Or you can always go back to the good old stopwatch and pen and paper and collect some data on the timings. Okay? So whenever in real life you do make a process map, okay, like this, or like this, or like this, it's going to be extremely important that you put information. So customer, you could put average waiting time here. Maybe you can on average customers wait 5 minutes or 3 minutes. How long does it take how long does it take a customer to place an order? And so on. And that timing data will help you do a lot of the analysis we're going to talk about, because once you have the timing data, you can do a lot of analysis on. Okay, so this is it for process mapping. We're going to look at analyzing the process next.